This is the corresponding confidence interval for the previous video with the hypothesis test for the one sample proportion. Just to revisit the question, we have 37% of 100 people agreeing with the survey question, and we want to know if this proportion is significantly larger than the expected 25%. So instead of using a 1% level of significance here, I'm going to use a 99% confidence interval. So the two things won't be exactly the same, but they will be very close. Formula we're going to use is Z-based for the critical number, and at 99%, that value is 2.576. Our formula will be p hat plus and minus our Z critical number, and our standard error now is p hat 1 minus p hat over n. Okay, pardon me, my handwriting's a bit terrible today. Let's just get that out of there and try a little bit better. There we go. So, what do we get when we put the numbers in? Well, the measurement, p hat, is 37%, so we'll use 0.37. We know the critical number is 2.576, and I'll show you where to get that on the Z table, or pardon me, the T table this time. Let's go over here. Here's 99%, so there's our 2.576. Remember, the infinity row is Z critical numbers. Back to our slide. Now we have to compute this. We're using the p hat value this time, so this will be 0.37 times 1 minus that, which is 0.63, divided by 100. So what do we get? We get 0.37, and we're going to add and subtract the margin of error. So let's compute that now. The square root value, by the way, is 0.0483 when we round that. And if I multiply that by 2.576, my margin of error is 0.1244. Subtracting that value from 0.37 will give us our lower bound, which is 0.2456. And if we add it, that'll give us our upper bound. I'll just do a quick computation. It's 0.4944. So we can say with 99% confidence that the true value of the proportion of people who agreed with the survey question lies between 24.56% and 49.44% of the population. And that's all there is to the confidence interval. That ends this video.